Hey guys, we're going to be extending the idea of the Pythagorean theorem and looking at distance today. So I want to start with this example, and this is actually a good example. It's a good graphical example here, and this is actually a part of your assignment. So I really hope that you pay attention. Again, I can tell whether you've really watched the video or not by knowing whether you got these answers right that we're actually looking at. But here you see this particular one, and I'm going to go ahead and label these points as they are. So you'll note that this one right here is, in fact, I want to change that color. Sorry. Let me get my eraser and get rid of that. Get you something you can see here. So this particular point is 5, 1. Okay. And you will note as well that we've got another one down here that's identified for. So this would be -4, -5. So what it's asking me for, it's asking me for the distance between those 2 points. Well, I can't just count up or count over because this is actually a slanted line. And so you think to yourself, how in the world am I going to be able to do this? Well, you can actually use Pythagorean theorem to kind of help you with this. And you may not see this initially at first, but if you look really, really close, you can begin to see that there is, in fact, a right triangle there, whether you really realize it or not. So what I'm going to do, I'm going to go ahead and change colors. Let's go with the blue. And so if you notice here, I could, boy, that was really, really crooked, but you get the idea. Right? And as well, I could go this way. And you notice all of a sudden now I have a right triangle. Okay, so now that I have a right triangle, I could look at this as a right triangle. And so if you think about what am I really looking for here, I'm really looking, this distance that I'm looking for is really the same thing as C. Okay, it's my hypotenuse because it's across from my right angle. And so then in order to find that hypotenuse, we know that now we need these two side lengths. Well, that's easy enough to do because here I know I'm at x equals -4, and over here I'm at x equals +5. So how long of a distance is that from -4 to +5? And you could just count over 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 9 units. So I know that that's 9 units across. All right, I can do the same exact thing from here. So if I count up, I can go 1, 2, 3, 4, 5, 6 units. So I know that this is 6 units high. Now I can use the Pythagorean theorem to help me to figure out what this distance in fact is. So let's go ahead and do that. So I'm going to have 6 squared plus 9 squared is going to equal C squared. Again, remember that C is actually this distance that I'm kind of looking for. So 6 squared is 36 plus 9 squared is 81, and that in fact equals C squared. So again, 36 plus 81 would be 117. That is correct. Equals C squared. Okay. So now I have to really look at this and see if there's any perfect squares, in fact, that I could get out of this. Okay. So I wonder if there's any of those numbers in that perfect square list that would go into this. So we could take a look at that. Think about some of those numbers that go in there. Pull out that perfect square list and try to see, in fact, if there is something that's there that you could pull out. So I'm thinking about 100 definitely will not. 64 doesn't look like it will. 81 doesn't look like it will either. 7's 49. Don't know that 49 would. So again, we're going through this list. 36, 117 divided by 36. And again, this is just kind of trial and error that you kind of have to go through to see, right? 36 will not go into it evenly. Let's see, 25. I'm pretty sure that's not going to go into it evenly. 16, I don't think would either. kind of running out of options, right? The next one would be 9, right? 3 times 3 would be 9. And voila, here we go. We've actually figured out something here. So I'm going to scoot this down and give myself just a little bit more room now. So actually, 117, remember, I'm going to take the square root here in order to undo my squared. So I kind of jumped ahead a little bit, but you understand what I was trying to do. So now I've got the square root of 117, and I've got to figure out if there's a perfect square in there. Well, it just so happens that 9 times 13 equals 117, okay? So now I could rewrite this, right? The square root of 9 would be 3, and the square root of 13 would have to stay underneath the radical because that's not a perfect square, and there would be my answer. Now here's what I want to kind of show you, because you can do this with a formula. There is a distance formula, thus that's the reason the title of this particular worksheet is distance formula. But I want to just kind of examine how in the world would you come up with that formula. Well, let's think about what we did here. We had to find this side right here, and we squared it, right? And we found this side, and we squared it just like we did with every other Pythagorean theorem problem or question. But how did we find this length of 9? Well, I had to take the point that I was at, the -4, and I had to find the difference between -4 and +5. I had to find out how many units I was going, okay? So I had to move over 9 units in order to do that. So let's just kind of think about this in terms of Pythagorean theorem for just a minute, and we'll kind of develop the distance formula, and then we'll take a look at how you could really use this, okay, for when you're not given a graph, because there are other problems on this page that you're not given a graph. As a matter of fact, a lot of times you're not given a graph. So let's think about it again. We've got a squared plus b squared equals c squared. That's the regular old Pythagorean theorem, right? How did I find this side length a? Well, in order to find this side length a, for example, let's just take our x coordinates. I had to take, and let's just go ahead and label these as x1, y1, and we'll call this one x2, y2. All that is saying this is point 1 and this is point 2. So really what I did, for instance, is I took x1 minus x2. I found the difference in those two, right? And then I had to square those. So x1 minus x2 squared plus I had to find the difference in my y term. So I had to find the difference from -5 to +1, which was 6, okay? So I really took y1 minus y2, and I squared it. And I want to say this as well. It doesn't really matter which direction you go in as long as you're finding the difference, because even if you get a negative number, you're going to be squaring that number. So it's still going to equal out, right? And then I really ended up with distance squared. Okay, so let's think about this. How do I get distance by itself? Again, distance squared is the same thing as c squared because it is, in fact, the hypotenuse. So in order to do that, I have to take the square root of this side to get d by itself. Well, if I do it to this side, I also have to do it over here, okay? So in fact, your distance formula is really just based on Pythagorean theorem, and it looks really, really complicated, but we're going to talk about really what it is. So d equals the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, this is your distance formula right here. So really what you're saying is you're taking the difference of your x's and squaring them. You're adding to that the difference of your y's squared, and then you just take the square root of the whole thing, okay? And it works exactly the same as what we did here. Now, I'm going to tell you, as long as you're given a graph, it's probably much easier to just do what we did over here, to just go ahead and kind of draw out the rest of your right triangle. For example, if we move down to number 10, really quickly, I could just go ahead and draw my right triangle, and I could figure out that this is in fact 1 unit, and this would be 1, 2, 3, 4, 5 units. And now I just do Pythagorean theorem and I'm done, okay? The issue in the place where this formula right here actually comes into play is when you're just given 2 points. So let's go up and work one example of that. just so that you've got one that you can see. So here we're going to look at number 2. And the first thing I'm going to do with number 2, I'm given 2 points and I'm asked to find the distance. Now, I could draw it out and then do all that. And if that's what you're comfortable with, that's fine with me too. Just remember, especially when you get to the ACT, it's all about time, okay? So first thing I'm going to do, I'm going to go ahead and label my points. X1, Y1, X2, Y2, okay? And again, just to help me to remember every single time, is I'm going to go ahead and write my formula out. So I've got D equals the square root, big old long one. That way you've got plenty of room to be able to do that. Okay, I'm going to go ahead and put x1 minus x2 squared plus y1 minus y2 squared. And again, it doesn't matter if you do one kind of order and then the other. It's still going to work out because you're squaring everything, okay? So let's take D equals, and I'm going to go ahead and fill in what I know, okay? So I'm going to keep my square root symbol. And so x1 is 8, x2 is -6. Now here's the thing you need to remember. These negative signs are part of your formula, okay? So those need to be there no matter what. So here we go. We have 8 minus a -6, and I'm going to square that, plus I have -4 minus a -6. And I'm going to square that, okay? So stick with me. It's going to get easier, I promise. D equals, and now let's go ahead and do our square root symbol again. Now we have 8 minus a -6. 8 minus a -6 is actually 14, so it just becomes 14 squared, plus -4 minus a -6. So that becomes -4, keep, change, -4 plus 6 equals 2. 2 squared right here. Okay, we're on the home stretch. D equals the square root. 14 squared would be, let's see, I don't know that right off the top of my head either. I should know that, right? Is 196. And 2 squared would be 4. So I end up with the square root of 200. So now I have to ask myself, is there any perfect squares that would be in the square root of 200? Well, if we just think through our list real quick, usually we made our list to 10. A lot of people made it a lot further than that, and that's great. But usually we made our list to 10. What is 10 times 10, or 10 squared? 10 squared is 100. So I could go ahead and rewrite this, I know, as 100 times 2. And then that leaves me with the square root of 100, which is 10, and square root of 2 has to stay underneath the radical. So the distance for number 2 here, using our distance formula, is going to be 10 radical 2. All right, so hopefully that makes sense. Again, if you're given a drawing like this one, probably a lot easier to just go ahead and finish out the right triangle and go ahead and do regular row Pythagorean, because that's basically what distance is. If you're given 2 points, maybe much easier to just plug in your information like this, okay? So hopefully this has been helpful to you. And if you have any questions or concerns, obviously reach out to me or Miss Willer, and we will be glad to try to help you with this subject. Have a great day.